Hello. In this video, I want to look at an application. So recall that if the function s of t, or if the function s of t gives the position of a particle at time t, then its velocity v of t and its acceleration a of t are given by v of t is the first derivative of position, and acceleration is the derivative of velocity, which would also be the second derivative of position. So suppose that the velocity of an object is v of t equals 6t squared minus 8t, and that the object is at 5 when time is at 0. Find s of t. So on A here, we want to realize that if these hold true, then the reverse happens as well using integrals. That means that s of t, or the position at any given time t, is the integral of v of t dt. And so I just plug in v of t here, and that's going to give me the integral of 6t squared minus 8t dt. And then just find the integral. Well, we still have the 6t to the 2 plus 1 is 3, and then you can think of this as dividing by 3 or multiplying by a third, either way. Minus, and then the 8t, and then add 1 to the exponent makes that 2, so think of that as dividing by 2 or multiplying by half, either way, plus some constant. So s of t equals 1/3 6t cubed minus 1/2 8t squared plus c. But we do need to simplify that, so 1/3 times 6 is 2t cubed, minus 1/2 times 8 is 4, so 4t squared, plus c. So s of t equals 2t cubed minus 4t squared plus c. But we don't want a function, we want the specific one. So I need to know what c should be. Well, if we go up here, it tells me that the object is at 5 when time is 0. In other words, that's telling me that s of 0 is equal to 5. So what is s of 0 here? Well, that's 2 times 0 cubed minus 4 times 0 squared plus a constant, which just gives me the constant. So c has to equal 5 because that is what s of 0 should be. Therefore, s of t really is 2t cubed minus 4t squared plus 5. And that is the position of this particle at any given time t. At least that's for this one. Now let's look at B. Many experiments have shown that when an object is dropped, its acceleration, ignoring air resistance, is constant. This constant has been found to be approximately 32 feet per second every second. In other words, 32 feet per second squared. That is, a of t equals 32, and technically there should be a negative sign there. The negative sign is used because the object is falling. Suppose an object is thrown down from the top of the 1,100-foot Willis Tower in Chicago. If the initial velocity of the object is negative 20 feet per second, because it's going downward, find s of t. So notice a couple of things we're told here. First of all, we're told that v of 0, the initial velocity, is negative 20. And we're also told that s of 0 is actually 1,100, because that is the height of the tower right here. And we're told that the acceleration is just negative 32. So let's see how that works. So on B here, if the acceleration is a constant, negative 32, I can find velocity, because the velocity is the integral of acceleration. So to figure this out, that's the integral of negative 32 dt, which just gives us negative 32t, plus a constant. So this is v of t. Now notice that v of 0 is what we need to know. So it gives me negative 32 times 0 plus c. And so remember that gives me c here, but remember, what is v of 0? V of 0 is negative 20. So it gives me v of, it gives me c is equal to negative 20. Therefore, v of t is equal to negative 32 t minus 20. Good. So that's v of t. Now I need to figure out what is a of t. What's the acceleration due to gravity? The position, s of t. So to figure out s of t is the integral of v of t. Now the velocity we just figured out is negative 32t minus 20, and then dt. So for this one, the integral of each one individually. So we have negative 32, and then t to the 1 plus 1 is 2, and technically divide by 2, or multiply by a half out front, either way. And then minus the 20 t to the, first power, and then divide by 1, so we don't really do anything. Plus a constant. But 1/2 times negative 32 is negative 16 t squared minus 20t, and then plus that constant. And this is the position at any given time t, but it's not the position because we still have the c there, which means we need to go back up here and realize that we need to look at s of 0 because we know that should be 1100. So s of 0 is negative 16t squared minus 20t, s of 16, negative 16 times 0 squared minus 20 times 0 plus c. And everything except for the c cancels. And again, this is equal to 1100. So c has to equal 1100. Therefore, the position at any given time t would be negative 16t squared minus 20t plus 1100. Awesome. So now we know all three of them. We know the velocity, the position, and acceleration of this, whatever this is. C. Use the equations derived in B to find the velocity of the object when it hit the ground and how long it took to strike the ground. Okay. So the first thing we need to know is when does it strike the ground? Well, to figure that out, we have to use what we just found. So on C here, we're going to look at S of t. The ground is when S of t equals 0. In other words, the height is 0. Let me do it the other way around here. So, set the entire function equal to 0 and solve. We get negative 16t squared minus 20 times t plus 1100 equals 0. And to be honest with you, I don't feel like doing this one in my head, but I don't like having a negative there, so I'm going to divide by a negative, making that, actually, let's divide by 4, making that negative 4. So, divide by negative 4, divide by negative 4, divide by negative 4, divide by negative 4. Why 4? Well, I know 16 and 20 are both divisible by 4, and so is 1100. So that's going to give me, let's just write it down here, 4t squared plus 5t minus, and then I'm going to do this on my head, 2830 is 7, 20 is 5, minus 275. All equal to 0. Awesome. And at this point, I recommend the quadratic formula. So t would be negative 5 plus or minus the square root of 5 squared minus 4 times 4 times negative 275. Then all over 2 times 4, which is 8. And again, if you have the quad program on the calculator, I would recommend just using that. And when you do that, just type in 4 for A, 5 for B, and negative 275 for C. And when you do so, you get the following. We get t equals negative, and let's just go to 2 decimal places, negative 8.94 or 7.69. Now notice that we actually can't use negative 8.94, and the reason why is because that actually happens before you actually threw the object. So as a result, well, we don't really want to, it happened before you threw it, so it doesn't mean anything, right? So there we go. So it actually strikes the ground after 7.69 seconds. And I think that's one of the questions that we have here, right? And how long it took to strike the ground. Awesome. So now we just need to find the velocity. And we're going to use the velocity function here, which is negative 32t minus 20. So we just want to know, what is the velocity at the 7.69 seconds? And then just type that in. So negative 32 times 7.69, and then minus 20. That's going to be negative 266.08. There we go. And the units here will be feet per second, FPS if you will, and the units up here are in seconds. Now, notice that this actually isn't true in the real world because there will be air resistance, and pretty strong air resistance, in order to, once you get going pretty fast. So it won't actually be negative 266.08, but if the tower was actually, on the moon, yeah, it would actually happen this fast. Well, not quite, because the acceleration due to gravity is a little bit different on the moon. It's about, what, a sixth of what it is here. So it'd be around 5-ish feet per second. Let me look that up. So on the moon, it's 5.3 feet per second. There we go. Good to know. Why? Well, it just is. Trust me. Anyway, let's actually answer the question and end this. So it will be traveling 266.08 feet per second when it strikes the ground .69 seconds after being thrown. Alrighty. I don't think I can get everything on here. So there was A and B, and there is C. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.